the topics which were for exam 1 and the next portion would be from slide number 25 to slide number 64, that is for your exam 2. And so what I'll do is I'll just go through each of these slides from the same PowerPoint, and then you can use these for your second exam, which is on 20th. So you can start with slide number 24, which is the difference between one sample t-test and a pair t-test. So one sample t-test is used to compare a single population to a standard value, right? So it's one because you just want to compare one sample with a standard value, while pair is to compare two populations, or just population before and after, right? And what does t-test measure? So it is a way of calculating a difference between two groups, right? So it will provide a p-value, and if the p-value is less than certain threshold, you will say that the groups are significantly different. Then which test should you use? So the choice of t-test, it can be a one sample t-test or pair t-test. It depends upon the type of comparison and the type of data you want to compare. Depending upon the data type, you can choose the type of test, and the standard threshold, right? The standard confidence threshold for any of these t-tests is a p-value of less than 0.05. So if the p-value is less than 0.05, then you say that it means that the data is likely to occur less than 5% of time under the null hypothesis. Means there is 5% of chance, or less than 5% of chance, that to be a random, right? So it has to be there is some significant difference between the two groups, and that is the reason why there is a significant p-value with the difference, which is, in other words, saying that it is less random difference. And again, we have to follow your null hypothesis and your alternate hypothesis, where null is when there is no difference, and alternate is when there is a significant difference. Then there is something called a z-scores and t-score. So z-score and t-score are again used to understand how many standard deviation differences are you away from the mean of your distribution. And z-score applies for z distribution data, and t-score applies for t distribution data. Then again, if you are using any of these tests, there are some of these assumptions. For t-test, the assumptions are data should be normally distributed, the groups have almost similar variance, the data are independent, and if your data does not follow any of these properties, then you may opt for a non-parametric test. So we will just focus on parametric t-test and not discuss any of these non-parametric tests. So then, how do you calculate a t-test in R? So say if you have an x variable and y variable holding 10 random values each, then we can use a function called t.test, right? So t.test is a function which applies a t-test on variables x and y, and you will have your p-value and the confidence value in a variable called t-test. Then what are distributions, right? So probability distributions are the functions that describe the likelihood of obtaining possible value at a random variable can assume. So you're using a probability, which is the calculation of chance, and applying that on distribution function. So the general properties of normal distributions that can be given by a formula called Px. P is the probability, x is uh, the likelihood that a random variable takes a specific value of x. Then the types of probability distributions. The first is the discrete probability distribution, and second is the continuous. The discrete is when you have discrete variables that can be round or round numbers, right? So it can be say 21, 22. So you want to calculate the number of books we had checked out from the library, and that can be say 1, 2, 3, 4, 20 or 22. So any of these round numbers are discrete probability distributions. This is another example of a discrete probability distribution where you are calculating the number of cards in any of these households, so 0, 1, 2, 3, 4 plus. There are three types of discrete distributions. The first is the binomial distribution, second is the Poisson distribution, and third is the uniform distribution. For binomial distribution, it looks into the binomial property, right? So binomial means 2, so it can just have two outcomes. So you toss a coin, so it can be a head or tail. That's a binomial distribution example. And to calculate binomial distribution, you use a function d by norm. For Poisson distribution, it looks into the events which are occurring at a interval of a time or space. Say you are calculating the number of cars which are crossing a bridge in a minute, then you can use a Poisson distribution function, and in R you can calculate that by using a function name called ppoise 16. And the second argument here is optional. You can add lambda or you can skip it, but you can have the ppoise value from this function. And the third is the uniform distribution. So uniform distribution is when you have the distribution of random numbers, selection from the continuous interval between a and b. Say you want to select say 10 random numbers from thresholds 1 and 3. You apply a function called R if in R, which is random uniform distribution. You are selecting random numbers following the uniform distribution. Next is the chi-square distribution, where you just so it is a type of distribution where you have you want to calculate distribution with some degrees of freedom and some independent random variables. So say you want to calculate a chi-square distribution with 7 degrees of freedom, you use a function q chi-square distribution over 7 degrees of freedom. Then the next type would be the F distribution, where you want to calculate distribution on 2 random variables but which follow the chi-square distribution, right? And also, unlike the chi-square distribution, it has 2 degrees of freedom, m1 and m2. Then the next type is the continuous probability distribution. So continuous probability distribution. So first type is discrete, second is continuous. Discrete is for discrete variables, continuous is for continuous variables. And for continuous, it is where you have non-round values, right? So it's the best way to approach these distribution functions, where you have distribution variables which are non-round, right? Say for example, you can have the temperature, which can be say 32 degrees Celsius or 2.5 degrees Celsius, 32.9 degrees Celsius. So we are assuming that these are non-round values, and so they are infinite. Right? So infinite variable is a continuous variable. So examples of these distribution would be exponential distribution. So in exponential distribution, say for example you want to calculate the checkout time in 3 minutes of Superman cashier. So to calculate that, we use a function called exp, which takes in the rate, which is the fraction of time. Then the next is the normal distribution, which we all know is just a bell-shaped curve, mean, mode, median at the center, one standard deviation. that is for again an example of continuous distributions. Last test is the chi-square test. Chi-square test is used to calculate again if there is a correlation between two variables of the same population. And to calculate a chi-square test, this is a formula, but we're not using this formula for our FLCs. Instead, we'll be just using an R function, which is the chi-sq dot test function. So this function taking into two variables to compare can calculate your chi-square value. Okay, so the next thing we'll do is we'll try to run these statements now.